Now let's take a look at how to do these normal probability calculations using Excel. So remember, there are two types of normal probability that we talked about. There is the general normal probability, and then there's the standard normal. We're going to start with the standard normal. And if you remember, for standard normal probabilities, the mean equals 0 and the standard deviation equals 1. And the function in Excel is always of the form, it's going to find the probability that z is less than whatever the given value is. There's an augment in it. There's a cumulative question in there. This cumulative question is always left as true because Excel only calculates cumulative probability. The probability of a non-cumulative probability is actually just going to give you the height of a bell curve, not an actual probability. So let's say we want to find the probability that z is less than 1.2. Now remember, oops, what happened there? Remember, we're looking at a bell curve here where the middle is the mean, and remember that's 0 in the standard normal. So positive 1.2 is up here somewhere. Less than is going to be this area. Remember, half the curve is 0.5, so this probability better be greater than 0.5. So we're going to put in equals norm dot dist, this normal distribution. X is the x value, which is 1.2, with a mean of 0 and a standard deviation of 1. And again, cumulative is always put in as true. Now, there are actually two separate functions in Excel. Here I use the regular normal distribution function, so I had to put in the mean of 0 and the standard deviation of 1. But if I could also use a standard normal function. So it's just norm dot s dot dist. So the dot s in the middle there is for standard. And now all I have to do is put in the z-score of 1.2 and true for cumulative, and I get that same probability. I don't have to enter the mean of 0 and standard deviation of 1, because by putting in the dot s, it's telling the Excel that this is a standard normal, so the mean is 0 and the standard deviation is 1. Finally, what's the probability of z being greater than 0.8? Well, the Excel only does less than probability, so I have to turn this into a complement. So it's 1 minus the probability that x is less than 0.8. So equals norm dot s dot dist. So I forgot to put my 1 minus in there. Let's go back before that. Put 1 minus norm dot s dot dist of 0.8 and true. When that makes sense, being greater than 0.8, about a 0.2119 probability works out. Now, if I wanted to do a probability of being between, let's say probability of being between a negative 0.9 and a positive 1.3. So now I have to do two normal probability calculations. The first one is for the upper end. So norm.s.dist for the 1.3, and again, put in true for my augment, minus the lower end. So this will be norm.s.dist negative 0.9, and again, we put in the true. Which makes sense. 0.719139 is, we're taking this right out of the middle of the high part of the curve, so that probably makes a lot of sense. Inverse calculations. Again, what Excel does, what it finds here, is the z-score for a given left tail area. So in other words, it's finding if probability that z is less than a equals some probability, let's say 0.1, it's finding the value of a. So if it equals norm dot inverse, INV, open parentheses. The probability is the 0.1. Now I didn't do the dot S, so I have to put in the mean of 0 and the standard deviation of 1. And there I get a negative 1.282 is the z-score that would correspond to a left tail probability of 0.1. Now I could do norm.s.inv, and now it's just assuming that it is a standard normal, so it's assuming that the mean is 0 and standard deviation is 1. And all I have to put in is the probability. I don't have to put in the mean and standard deviation in that case. So what if I want to know the probability that z being greater than a value is 0.2? So again, I have to look at a complement. The probability that z is less, if the probability of z being greater than a is 0.2, the probability of z being less than a is 0.8. And so that's what I have to enter in here. Norm.s.inv 0.8, and I get that that's a z-score of 0.84. What if I want to find the 60th percentile? Well, remember, 60th percentile is just the value such that 60% of other values are smaller. In other words, it's the probability of z being less than this value equals 60% or 0.60. So normal.s.inv of 0.6, and we get the 0.25. So the 60th percentile here is 0.25. Let's find the values such that the values such that the middle 90% of the data is between them. So what we're looking at here, we have a bell curve. We're taking 90% out of the middle, which means there's 10% outside of that. That 10% is split 50-50, 5% on each side, because the curve is symmetrical. So 5% on each side of that middle 90%. So this cutoff here is a left tail area of 0.05. This cutoff here has a left tail of 5 plus 90 is 95%. So that left tail area is 0.95. So let's calculate those. So the very left one equals norm.s.inverse 0.05. And for the right end, it equals norm.s.inverse 0.95. Get the same values, one positive, one negative. And since it's a standard normal, that makes sense. For general normal distributions, the mean can be anything, and the standard deviation is anything greater than 0. So for a population with a mean, let's do this, mean equal to 30 and standard deviation equal to 9. We're going to find, now this is x, not z anymore. The probability that x is less than 40. So we're going to use the norm.dist, norm distribution, no dot s anymore, because this is not standard normal anymore. So we're looking at less than 40 with a mean of 30 and a standard deviation of 9. And of course, we put in true for cumulative, and we get a probability of 0.867 or 8667. Probability of x being greater than 25. Well, again, the normal probability function in Excel only does less than, only does left tails, so we have to use a complement. This is 1 minus the probability that x is less than 25. So that's what we're going to enter in their function here, 1 minus normal.dist. 25 is our x value, a mean of 30, and a standard deviation of 9. And true for cumulative. So there we get that probability of 0.71074. Or if we wanted the probability that we are between, that x is between 12 and 35. Well, we use two normal functions here. Normal.distr. First, we start out with the upper end, the 35, with a mean of 30, standard deviation of 9, and true. Minus, we do the function for the lower end, normal.dist. The lower end is going to be 12 with a mean of 30, standard deviation of 9, and once again, true. We get 0.68799 as that probability, and that makes sense. So our inverse calculations. Well, just like with the standard normal, it finds the x value instead of just a z-score. It finds an x value for a given left tail area under the curve. So in other words, it's inverting probability that x is less than a value. It's equals whatever probability. It's finding the value of a for that situation. So let's find a such that the probability x is less than or equal to a, or just less than a, it doesn't matter because it's a continuous probability, equals 0.95. Now we're expecting this to be a pretty big value because here's our bell curve. The mean would be in the middle. Probability of being less than the mean would be 0.5. Well, 0.95, to get that area, we're going to have to be way up here. So this is going to be a pretty large value. So equals norm.inv. The probability is 0.95. The mean is 30, and the standard deviation is 9, giving us that value has to be 44.8. So probability of x being less than 44.8 is 0.95. Or how the probability that x is greater than a equals 0.9. So this is saying we have, come on, here's our bell curve. Greater than is 0.9. So a is down here. This is a. And this probability here colors in to be 0.9. But remember, our function only does left tail area. So if this is 0.9 in here, the left tail has to be 0.1. And so that's what we're going to use in our inverse calculation. Equals norm.inv, probability of 0.1 with a mean of 30 and a standard deviation of 9. Oops, I got a 0 on it instead of a parentheses. There we go. So 90% of the data is greater than 18.47. Find the values such that the middle 80% of the data is between them. So again, we are looking at a bell curve. We want the 80% in the middle. If 80% is in the middle, that means there's 20% outside of it, and that is split equally to both tails again because of symmetry. So 10% is missing on each end of the data. So that means this cutoff has a left tail area. 10% corresponds to 0.10. Over here, this would have a left tail area of 10 plus 80 is 90%. So that'd be a left tail area of 0.90. Now, unlike the standard normal, remember in the standard normal, the two values were the same number, just one positive and one negative. But that's because the center of the curve was at 0. For a general normal distribution, the center of the curve is not at 0. So these will not be the same value, just one positive, one negative. So let's do the left end here, the 10%. So norm.inv, 0.1 with a mean of 30, standard deviation of 9. And then let's do the right end here, which is the 90%. So that equals norm.inv 90% or 0.9 with a mean of 30, standard deviation of 9. So we get 18.47 and 41.53. But note that those are the same distance from the mean. Remember, the mean of this is 30. So the center here is 30. Well, 18.47, if we round to 2 decimal places, is 11.53 smaller than that. Up here, this end is 41.53. That is 11.53 larger than the mean of 30. So the two values we get are still going to be equidistant on either side of the mean. They're just not going to be one value positive and one value negative anymore. So those are normal probabilities using Excel. You can see those of you that are used to using a calculator works very similar to the cumulative. The inverse function works almost exactly like the normal inverse function on the calculator. The normal probability function itself works more like the binomial CDF or the binomial cumulative function. So we do have to do a little bit of adjusting there. So with that, hopefully that works well for you. If you have any questions, please let me know. Otherwise, hopefully we'll see you in our regularly scheduled class.